All right, here's another one. A radioactive element. Let's pay attention and stop our conversations, please. They're getting kind of annoying. A radioactive element decays at a rate of 0.73% per year. If you start with 15 grams of the element, how much is left after 150 years? Now, is this growth or decay? Decay. So we're going to add or subtract? Subtract. Because it says it in the problem. So this is going to be P times 1 minus R to the T power. So decay is going to give us where we have to subtract off the value here. Now, what's P equal to? What do we start with? 15 grams. So we got 15 grams to start with. What's my R? What's the decay rate? 7.3%. Which is 0.073. So if you put 0.73, it's actually 73% decay rate.
It's
so you have to be careful about when you're dealing with single-digit decay rates or growth rates. You have to be careful about putting that 0 in there. And T is equal to how much? 150 years. So A of 150 years, well, what's the original amount? And then 1 minus 0.073 to what power? Now, the nice thing is, ladies and gentlemen, you don't have to calculate the 1 minus the 0.073 because our calculators will do it for us. So now we go to our calculator. After 150 years, if this was just sitting on a shelf for 150 years, then we would only have 0.000173 grams of this element left. It goes away. Do you know how it goes away? Well, we can. You can think of it in terms of half-life, and a lot of times, if you know the half-life, then you can figure out what its actual decay rate is, and that's kind of working backwards, and you guys don't know how to do that yet. But little things like electrons jump off, and parts of it jump off, and that's just what happens. Everything decays. And it decays by, when you're talking about your chemistry class, you know how everything is circulating around the atoms and all that, and then all of a sudden, parts fly off. That's radioactivity. That's what's going on, is when different parts of the element actually can escape the pull of all the different forces that are there. And every element decays at a certain amount. And for that element, it's constant. And That's one of the cool things in nature, which allows us to do things like carbon dating and dating with uranium and figuring out the age of rocks and the age of organic tissue and all that kind of stuff. That's why we can, if we find a fossilized tree, we can actually date it back based on the carbon that's in there because we know the decay rate of carbon. So I think it's carbon-12 is what we can use. And I think it's like uranium-234 is what we use sometimes. And there's other ones that are a little bit more stable that we can use for rocks. Actually, dating rocks is a lot easier to do and a lot more accurate than using carbon dating. Because carbon dating, there's a little bit more error that goes into play there. Or not error, but the decay rates make it not as accurate as other methods of dating things.